Okay. Hi everyone. My name is Soumya. I am Prime Minister Research Fellow at IIT Gandhinagar, and welcome to the first interaction session for this week. Uh, I hope you have gone through the week one's content for control systems, and we will be solving some sort of problems, and I'll be giving you insights into what goes on here. So we'll start with some basic maths problems. Since this week there has not been much coverage, it has basically been maths only and a basic introduction. From the next week you'll be having some more things which goes more into control, like transfer function, poles and zeros sort of thing. As of now it is going to be a simple maths kind of problem that would basically build the foundation for your whole course. So we'll start. So if we just go with some basic maths, like all of you are aware how to find the roots of the polynomial. Later on you will see that all of these, when present in the denominator, make up the characteristic equation. So I would prefer if you all also go on solving the problem along with me. So in case this problem was solved, because it has nothing very important to
Madam,
do. Yeah.
madam, please enlarge the screen, madam.
You want, okay.
Screen. Please enlarge the screen, madam.
Is it visible now?
No, madam. Still.
Just a second. Just a second. Is it okay?
Okay, madam.
Okay. Yeah. So the first problem is where we just want to find the roots of the solution. So you are already aware of this iota thing. So that is a thing here. So here the roots that are present here are of complex nature and they are conjugate pairs. So you get minus 2 plus minus 2j. From the next question, please start solving and we would be solving them together. So in this case, as you see that there is a complex number written over here, and then I want to know what is the magnitude of this complex number. So can someone answer? Surya, can you please mute yourself? Okay, has anyone got the answer? Yeah. So what we do is we take the uh, square of the real part plus square of the imaginary part under root, and we get 4, which is equal to 2. Okay, so I hope everyone knows all of these already. Now the next question, yeah, it's 2. The next question is uh, given this complex number, what is the phase angle? So how would you find the phase angle for this? Okay, just wait. I hope this is visible now. Yeah. So what is the phase in degrees for this question? How would you solve this?
Minus 30 degrees, madam.
Yes, minus 30 degree is the correct answer. So what you are doing is basically you have j in the denominator. So you are supposed to uh, not have any complex term in the denominator. So you would, what you would get is when you multiply numerator and denominator both by j, you'll get j plus, and it would be minus root 3 because j square is minus 1, and here also you would get minus 1. This would take you to uh, root 3, uh, yeah, this would take you to root 3, and here it would be minus j. So when you take, it would be tan inverse of minus 1 upon root 3. That would be minus tan inverse of 1 upon root 3. That would be minus 30 degrees. Okay. So yeah, here is a question. Uh, since we are already familiar with differentiation and integration since class 11th and 12th, so can you find the solution to this ordinary differential equation? It's a simple maths problem, and as a hint I can say that it goes with variable separable method. Has anyone come up with the answer?
Minus e power 2t, madam.
Yeah, right. So how do we solve this is, when you have y dot t is equal to 2yt. Now what you want to do is, so this is basically dy by dt, and this is, okay. So what you do is you try to have this, t is already a variable here, and here you can have 2t, 2 dt, sorry. Then you can take integration on both the sides. Here you have ln y, and here you have 2t. But when you integrate, you definitely get a constant, which we can take here as c. Now y can be written as e to the power 2t plus c. So if it is e to the power 2t plus c, we can break it as e to the power 2t into e to the power c. So y can be written here as e to the power 2t into, let's say, some constant a. Now we just want to find the value of this constant. When you want to do this, what you would do is, what was the value of y here? Minus 1. Minus 1 is when t is equal to 0. So basically e to 2 into 0 into a. So the value of a is minus 1. So here what you get is y is equal to minus e to the power 2t. So these are basic problems that you will be using everywhere. Now, so the solution that you got here, y is equal to minus e to the power 2t. So the next question corresponds to the same question, that which one of the following statement is true regarding the solution. So what do you think? When the magnitude goes to infinity or 0, what could be the result here? Let's say if the magnitude uh, uh, as time tends to infinity. So if t tends to infinity, what would be the output here?
Magnitude tends to infinity, madam.
Yeah, the output of the magnitude of the output tends to infinity. And if t tends to 0, it is just the initial condition then. So if it is initial condition only, that means it is at t is equal to 0. So what would happen is y is equal to minus e to the power 2 into 0. If this is the case, then y would be minus 1. So this is what was the initial condition that was given to you, that y0 is equal to minus 1. So it's the same thing. second, someone wants to join, I guess. Just a second. Okay, so the answer was minus e to the power 2t. So as time tends to infinity, the output also tends to infinity, so this would be the answer. Okay, so before we proceed with any other question, I want to let you know is that this question you have solved using integration and differentiation. Let's say I have some easier way of solving and it is not integration and differentiation, then it would be easier. One second. Just a second, I'll admit people. So if we are able to have some method in which we are very easily able to solve the differential equations, that would be of much help to us. So Laplace transforms are one of those ways in which we solve. And in case you don't know, so what Laplace transform does is, let's say we want to find Laplace transform of a function, then it is basically 0 to infinity ft e power minus st dt. So this is the thing you are going to use, where s is the frequency domain parameter that is used in Laplace transform.
Ma'am, the
So
screen is not visible.
screen is not visible. Okay. Is it visible now?
Yeah.
Okay. Okay, so what I was saying was Laplace transform of a function which is ft is minus infinity, I'm sorry, 0 to infinity ft e to the power minus st dt. So this is the definition of Laplace transform, and we generally use it for frequency domain analysis. So here S basically represents j omega term. It also has a real part, but we can say that it represents the frequency domain parameter. Now what we are going to do is here uh, this table is very important and we'll be using this throughout. So I'll teach you the way you have solved the differential equation right now. It can be solved very easily using this Laplace transform method. So I would suggest you, if you can take a picture of this uh, entire table, it would be helpful for us. I assume it is taken. Now the question that you had earlier, y dot t is equal to 2yt. So the same question, y dot t is equal to 2yt, and let's say uh, the initial condition was y0 is equal to minus 1. Okay, y0 is equal to minus 1. We want to solve this using Laplace transform method. So what we'll do is we will take the Laplace transform of all these things. So if you see in the table, what you get here is this is the f dash t term in 15 number. So for any differential kind of function, what you're going to do is the Laplace transform is going to be s into fs minus f0. So keeping that in mind, here it would be s into ys minus y0. Okay. If this Laplace transform is taken, a s operator is used instead of t operator. Now, on the other side, it is just yt. So for yt, you would have just ys. Now it becomes a simple algebraic equation. There is no integration, there is no differentiation. Here you are, so everything is super simple. Now what you want to do, bring ys on one side. So what you will get is ys s minus 2, sorry, ys into s minus 2 is equal to y0. So what you'll get is ys is equal to y0 is minus 1 upon s minus 2. So this is the thing you have got. Now if you can see one more thing, there is a function called e power at. So if e to the power at is a function, its Laplace transform is 1 upon s minus a. So if the function is e power at, it is going to be 1 upon s minus a. So according to the same thing, what do you think should come here? Okay, so this is in s domain. Now we wanted the answer to be always in t domain because we want to work normally in time domain, and you want to even match the answer with the previous answer that you had got for integration and differentiation. So when you have the answer in Laplace domain, taking it into t domain, how would you get? So if you can compare this and this, can you tell me what could be yt here in terms of exponential power?
e raised to 2t.
Yeah, so minus 1 will already be there and into 1 upon s minus 2 e to the power 2t. So hence you have got the here now the answer here very simply. It is just minus e power 2t. So this is the way you work in Laplace domain. Okay. Okay, so this is the next question. Uh, Please solve this using the simple t domain integration and differentiation, which you already know, not Laplace transform, and let me know the answer. Please note down the question. Has anyone got the answer?
Option C, madam.
Yeah, 1
1
minus
1
e.
minus e power
Yes, yes, correct. So how do you solve this? Is what is the method that you have used? Can you tell? Is there some name to that method?
It's my complementary function and particular integral.
Yes, yes. So that is the way you remember the things. And if you go into 12th class mathematics, it would use integrating factor method. So that comes
Yes,
as
ma'am.
particular integral and complementary function. Sorry. So what we really do is, if I tell you the simple mathematics, it would be like okay. So it would be dy by dt plus 2yt is equal to 2. Then what you're doing is you want to have some integrating factors. How integrating factor method works? It works like dy by dt plus, let's say you have some p into yt is equal to q. So what you really do is you find an integrating factor, and it is e whatever p is there, and you want to integrate it with respect to t. So in our case it is e to the power 2 into dt. This dt should come here. Yeah. So when you do this, sorry, it should not be like this. Now when you do this, what you get is e to the power minus 2t, e to the power 2t. Now you can multiply using this to the whole equation. So what happens is e to the power 2t dy by dt plus e to the power 2t 2yt is equal to 2 e to the power t. So what you can essentially find here is this thing is basically a differentiation of e power 2t into y. So this is the important thing here, and on the other side you can just integrate to power 2t dt. When you integrate both the sides, it is e to the power 2t into y and on the other side also you are integrating. Now when you integrate this, what you get is e to the power 2t, because 2 cancels out it when it comes out from here, e to the power 2t plus c. Now you want to just solve for c. So what you can write here is yt is equal to 1 plus c e to the power minus 2t, because we want to get rid of this e to the power 2t everywhere. So we are just multiplying it by e to the power minus 2t. And when you multiply and apply the initial conditions, so you can see y is 0 for t is equal to 0. So what you get is 0 is equal to 1 plus c into e to the power minus 2 into 0. So c here is minus 1. So when you get c is equal to minus 1, so eventually you get is yt is equal to 1 minus e to the power minus 2t. So this is the way you get the answer. If you solve by the normal process and you see that it is a normal integration factor, you need to know that yeah, there is something complementary function and particular function, and hence you get the answer. Okay, so if this is the answer, if 1 minus e to the power minus 2t is the answer, what would happen? What is the magnitude of the solution as time tends to infinity? So let's say if this t tends to infinity, what is yt? Y infinity, what is it? Just put infinity there. So if you put infinity, it would be 1 minus 2 into infinity. Now e on the power, so for power of e, you have something which is very negative, very negative. That means that it is going to really diminish this thing. So it would just be 1 and this whole thing would tend to 0. So this is the way you do. Now another question related to the same, yt is equal to 1 minus e power minus 2t. Uh, can you tell which one of the following statements is true? What kind of behavior would it show? So just going with the first option, I would like to ask you, what happens to the output as we increase the value of t? Let's say initially t was 0. So what is the value you get when t was 0? Can someone tell? It's very simple. Please try. Yeah, I got disconnected. Okay, I'll share the screen. Okay, is the screen visible? Can someone confirm?
Yes, ma'am.
Okay, thank you. So yeah, I don't know where I lost the connection, but I think I had completed this problem. And yeah, so I hope this was clear. So the magnitude of the solution as time tends to infinity. So if the solution, our solution was yt is equal to 1 minus e to the power minus 2t. So as y tends to infinity, you want to put infinity in place of t and then see what is the value. So if you have some very large value at the place of t in the power of e and it is negative, that means you have a very high value, e power minus infinity kind of thing. So it is really going to diminish this term and we are going to have 1. Now the next question that I was asking was, and probably I lost the connection, was this. Which one of the following statements is true about the solution to problem 6? So can you tell which of these statements is true? So let's say I want to check the first statement only. So the value of the output monotonically increases from its initial value to final asymptotic value. So what does this statement really mean? It just means that what happens as time approaches infinity. You start from t is equal to 0, you reach till t is equal to infinity. What happens in between? So can someone tell me if this yt is my solution to the problem, the output thing?
Yeah, madam. Monotonical link.
Yeah, it monotonically increases. And please check the other options as well if you think uh, it could be the answer. Okay, so what happens is when t is equal to 0, y0 is just equal to 1 minus 1. Because t is equal to 0, then e power 0 you would have 1 only, and 1 minus 1 is 0. When t is infinity, then what happens, as we saw earlier, that the second term is whole 0 and we only get the first term. So you really go from 0 to 1 as the solution. So when you have this thing, so it is monotonically increasing. Just to mark safety, take some safety measures. You can check at some other points also. Don't check just at t is equal to 0 and infinity, rather take some between the middle points also, and then you can get the answer. So the first option is the answer. It does not exhibit oscillation because there is no sine and cos function here. The solution is a linear function of time. It is not a linear function of time since we have something as a in the exponential. Then the solution is constant with time. No, it is not constant because t term is present there and it is always changing the solution. So this is the way you could look at this. Now, yeah, what I want to say is, so you all already have this question with you. Y dot t plus 2yt is equal to 2. And you had y0 is equal to 0. Can you get the same solution, which was 1 minus e to power minus 2t? This was your answer. Can you get the same solution if you use Laplace transform method? So what was the Laplace transform of y dot t? If you remember, we used it in the last question. So there is a rule to remember all of these things. So whenever there is differentiation, you get an s before ys. So what happens is, अगर सिर्फ yt का Laplace transform लेना है, so it is just a change in variable. So yt is always in small because it is a function and we in general denote it by small letters. लेकिन जब उसका Laplace transform लिया, so we change the y to capital Y and s remains small only. So this is the Laplace transform. Okay, and this was the time domain function only and nothing more than that. तो उसी तरह से अगर yt का ys है, तो if it is y dot t, तो इसका क्या होगा, वी वांट टू नो. तो y डॉट टी है, मतलब yt तो था ही, उसको डिफ्रेंशिएट किया है, तो इट इज सर्टेन दैट देयर वुड बी अ वाईएस टर्म, ओके, करस्पॉन्डिंग टू दिस. नाउ व्हाट वी वांट टू नो कि इसका लैप्लास ट्रांसफॉर्म क्या होगा, तो कुछ तो वाईएस करके होगा. अभी क्या होगा, तो देयर वुड बी एन एस बिफोर इट. सिमिलरली इफ इट इज इंटीग्रेशन ऑफ वाई टी, अगर एक इंटीग्रल है, जस्ट वन इंटीग्रल, इट वुड बी वाई एस अपॉन एस. So these just you need to know, if it is differentiation एक s बाहर आएगा, if it is integration it is going to be by s. Now if it is y double dot t, then तो s square will come into picture, s square fs, and there would be again two more terms which would, so it would be like f dash 0 it is, and this is s into f0. So these two terms also come as an initial condition, but the point is you should remember that differentiation means s is before. So in this case y dot t, एक s बाहर आ गया, ys बाहर आ गया, and there is another thing called y0. ठीक है, we और फिर we take the Laplace transform of 2y2, then it is 2ys only, and here you have 2. Now what this 2 would do, so if you have seen, just a second, someone wants to know, yeah, if you have seen the table which I showed you, so I hope all of you have the copies of the table, and look at the very first function, which was just 1. If there is just a constant function 1 in the time domain, you would have 1 upon s in the Laplace domain. Is it? The same thing is here. Here it is 2, then it would be 2 by s. And it is unit step function kind of thing, where input is constant. So this is the thing you get, sys minus y0 plus 2ys is equal to 2 upon s. Now what we do is, y0 is already 0 from the initial condition that is already given to you. So it would be s plus 2 into ys is equal to 2 upon s. Then what you would have, yeah, this is the thing, 2 upon s into s plus 2. Okay, can someone split it in such a way that you get, let's say, some constant a upon s plus some constant b upon s plus 2? This is the partial fraction method that we had in our class 12 syllabus.
A is equal to 1, madam.
A is equal to 1 and b is equal to,
Minus 1.
a is equal to 1 and b is equal to minus 1. So it is very simple. What you really do here is, I don't have extra page here, okay. So what you do here is, you take 2, you write like this, 2 upon s into s plus 2 is equal to a upon s plus b upon s plus 2. Now what you do is solve, just solve this. So you will have 2 upon s into s plus 2, and you will have a into s plus 2 upon s plus b into s upon s plus 2. Now sorry, both of these would be in multiplication, ये कट गया, ये कट गया, so 2 is equal to a into s plus 2 plus b into s. Now you just want to find this, put s is equal to 0, you will get one equation, put s is equal to minus 2, you will get another equation. So you get the values of both a and b here. So that is why the student said that it is a is equal to 1 and b is equal to minus 1. So what you get is ys is equal to 1 upon s plus minus 1 upon s plus 2. These questions will help you a lot in your assignments. You might have similar kind of questions. Now if you take yt, so abhi, can someone refer to the table and tell me what, for what function in time domain we had the Laplace domain as 1 upon s? Can someone tell from the Laplace table? Okay, I'll show you. Yeah, this was the table. So here is 1 upon s. So we have 1 corresponding to this. So it is called inverse Laplace when you want to go from frequency domain to time domain. So this is, it would be 1. Now I want an answer for this, minus 1 upon s plus 2. What would you get?
E to
minus e
power
power
minus
2t.
2t.
Right, very good. So this is the answer that you got from Laplace domain. So you'll have these things always in control systems, because you always will want to find some kind of relationship between output and input. So when you want some relationship between, let's say I want the speed of the motor, and I have some value to be given, let's say input current, then what is the relation, what could be the relation between output and input? That determines my plant. Now what is the plant is uh, represented by a differential equation, and you can always have transfer function for the same. Okay, please solve this question. This is a simple quadratic equation question. So both the roots should have, should just have real sorry, negative real part for k.
K greater than 0, madam.
Yeah, right. You just have to look at the real part and you get the answer. Okay. Okay. So this is also a very simple question. You just have to find the roots of the equation and tell me which of the statements is correct. Now, if yeah, so for complex plane, let me tell you what complex plane is. So I am always talking about S plane, SS parameter. So there is something called S plane, where you have real parts here, imaginary part here. So you always want to represent a complex number जिसका imaginary part would lie on x-axis, sorry, real part would always lie on x-axis, imaginary part which is with j would lie on y-axis. So let's say I say minus 2 plus 2j. So it is minus 2 is the real part, plus 2 is the imaginary part. So this is the point where this point would lie. Now if I say minus 2 minus 2j, so it would be minus 2 is here and minus 2j wala part is here, then it would be this point. So this is the way you define. Now when it says roots lie in the complex plane, left half or right part, it means corresponding to this imaginary axis, this point is 0,0. इसके लेफ्ट में है या राइट में है, या फिर इट इज ऑन द इमेजिनरी एक्सिस और इट इज ऑन द रियल एक्सिस. सो दैट इज द सिंपल क्वेश्चन. नाउ यू कैन टेल मी इफ यू फाइंड द रूट्स.
Ma'am, right half of the complex plane.
Right. I hope everyone is getting this answer. Now what we'll do is, yes, so in week 1 it was very basic maths. Now in week 1 you learned something about causal system. So do you have any idea what causal systems are?
Yes, ma'am. The output depends on past inputs and past outputs as well as present input.
Right. So there is nothing like you need to know about the future. It would never depend on some future thing that is going to happen. Any causal system just depends on the past and present outputs. The past output, past input, and present input only. So when it is said a causal system is what all of these, so see, causal system is always non-anticipatory. Now why it is called non-anticipatory? So for anticipatory you mean, uh, let's say all the inputs are zero, you do not have any input. Okay, let's say there were two inputs and output is some non-zero quantity. Let's say it is C, some non-zero quantity. So that means when you do not even have any input to the system, you are getting some output. The system is anticipatory here. Whereas in causal system what happens is you have dependencies only on the past things. So when you have dependencies only on the past things, you are not going to have any output if no input is present. So a causal system is always non-anticipatory. Then, yeah, a system whose governing equation is yt is equal to tut is, what are the options? What is the answer here according to you?
Linear and time variant, madam.
How do you say a system is linear?
A into x1 of t plus b into x2 of t is equal to a into y1 of t plus b into y2 of t, madam.
Yes. So
Linear.
basically, it should follow the superposition principle.
Yes,
So,
madam.
what happens is, if y1 is, let's say, some signal which is t into u1 of t, y2 is t into u2 of t, then y1 plus y2 here is t u1 plus t ut, which is essentially uh, t of u1 plus u2. So it is, if this were a new signal y, this is a new signal u. So basically you again get this only for a combination of signals also. So it is a linear system. Now why it is a time varying system? Because you have t explicitly here. So if it is t is equal to 0, yt would be 0. If t is equal to 1, yt would be ut. If t is equal to 2, yt would be 2 ut. So as time varies, your output is also varying. So it depends. Now, another question is, consider a washing machine unit. Okay. No, one more thing. I had another thing in mind. What would you say about this? Is this system linear or non-linear?
Non-linear and non-time invariant, madam.
Yeah, it is time invariant because you do not have any t appearing anywhere in the equation. Now, why this is a non-linear system? Because if you apply the same thing here, same thing, what you would get is y1 is equal to sine of x1, y2 is equal to sine of x2. Okay. Now, if you do y1 plus y2, you will get sine x1 plus sine x2, and what you actually wanted was sine of x1 plus x2. They both are not equal. So we wanted कि अगर ये वाला सिस्टम है तो हमें मिल जाए y is equal to sine of x, where y is combination of y1 plus y2 x is combination of x1 plus x2. But what happens here? You get sin x1 plus sin x2. Now this and this is not equal. If these are not equal, hence the system is non-linear. So any system with these trigonometric functions, ln, exponential functions, ln I said logarithmic functions, so all of these do not follow the linear principle. All of them have non-linear graphs as well. Now, consider a washing machine unit to which an electric current is provided as input and rotational speed of the drum is output. So let's say current is the input to a washing machine and rotational speed is the output. So if you want to find a relation between electric current input and rotational speed output, so what is the problem you are solving? So there are some things which you already do. So if you are from electrical engineering, you'll have a subject called network analysis and synthesis. So synthesis is you want to synthesize the network. So if you have input with you, if you have output with you, and then you want to find out कि ये washing machine का क्या ही differential equation रहेगा, then it is a problem of synthesis. You want to synthesize a network given the input and output. If you have the input with you and if you have washing machine का ordinary differential equation क्या होगा, then you just want the output कि omega t क्या होगा. So that is a prediction problem because you have the input, you know what is the plant and you just want to find output. Everything was known to you, you just have to get the answer. Now in control problem what happens is you know what is the washing machine, you know what is the output you want and you want to provide a suitable input. When you don't know कि input ही क्या दें उसको ताकि हमें, let's say you have a motor and you say कि I want to drive it at 1500 rpm, a DC motor 1500 rpm you want to drive it. अभी 1500 rpm पे ड्राइव करने के लिए और मुझे मोटर के भी डिफरेंशियल इक्वेशंस पता है, व्हाट इज द इनपुट आई शुड गिव, व्हाट इज द करंट आई शुड गिव टू गेट दैट स्पीड, दैट इज अ कंट्रोल प्रॉब्लम where you really want to know what is the input that is to be given. Okay, and estimation is where you do not get the exact answers or exact values of the output because you do not have all the sensors available, you are not able to measure everything that you want to measure, and then you use some sort of estimation method which you will read in control later on, you will have some observers and all. Okay, so yeah, the next question is which of the following is an example of open loop system. Now when you say open loop system, so can someone say what is a closed loop and what is a open loop system?
Ma'am, closed loop system is a system in which the outputs depends upon past as well as the future. That means this system has a feedback type of something which depends on the past value as well. For example, the air conditioner has a feedback. It's automatically set the temperature according to the changing temperature of room. And the
Right.
open loop systems does not have any feedback systems.
Yes. So you know what is feedback. So I'll reiterate it. So uh, it was also taught in the course. We usually know, let's say the same washing machine problem. So if we talk about open loop, what do we say? This is my washing machine. It has some differential equation associated with it. You will soon know in the second week that how we will change to transfer function lingo. But for now, I'll be using differential equation. Now you have some output coming out from it and you're, let's say, giving it some suitable voltage and you're getting some output. Abhi you have set ki I would drive the washing machine at 240 volts and my clothes would dry washing machine is saying that it would dry in 1 hour or so, so it would happen. But you have no way to measure if so your output is my clothes are being dried to what extent. Now you never know that what is how much moisture is left, or what is the threshold you want that yeah, after this my clothes are dried. You never know because everything is an open loop. You do not have any information about what is happening on the output side. You just think that yeah, it is going to take this much time or itne mein ho hi jayega. So that happens in open loop control. You really don't worry about what is the output here. हाँ, it has to be between certain value. तो मैं एक input दे रही हूँ और फिर उसके बाद कुछ तो output आएगा and that would be desirable. But in closed loop, what you do is, this is the washing machine only. This is the some voltage that you were giving. This is some output that you are controlling, and you take this as a feedback कि मेरा output इतना आ रहा है. This is the moisture level here. और and you say कि what should be the reference value, कि मेरा moisture level should be some value. So you say your moisture value should be some value, and what you get from here, from the output, that is also a value. So you get a difference between both of them. Let's say a difference of 5. Now you want to you get an error basically कि what I wanted and what I am getting. You pass that through a controller. Now the controller gives you the perfect input for the plant to be taken. Just a second, I'm getting, oh, no one is here. Okay, yeah. So basically you have a controller that takes care that the sufficient voltage, now it is no more 230 volts, sufficient voltage is sent to the washing machine so that your clothes are drying. It could be current also in other cases if not voltage. So it is being dried. So what really happens is you always have some reference input. It could be a speed. Let's say if this was not washing machine and this was DC motor only, and you wanted some speed of the motor. अभी ये मोटर का स्पीड है, कुछ भी आ रहा है, मेरा रेफरेंस स्पीड मैंने बोला कि आई वांट 1500 आरपीएम. सो इट इज गोइंग टू टेक द स्पीड आउटपुट जो फीडबैक में आ रहा है. लेट्स से एट सम पॉइंट इट वाज 1200 आरपीएम. It is going to take the speed 1500 rpm is going already there. Find out the error. Error will be processed in the controller. Controllers are of many types and you'll see them in the later classes. So इससे process करके a desired input is sent, which is let's say current, कि हाँ this much current should be given to the DC motor to generate an rpm of 1500. So this process continues and the output is always maintained at 1500 rpm. So we take care कि हाँ DC motor का ये speed हमेशा के लिए होना चाहिए. So that is basically what we do here. Okay. So हाँ, what we have is reference input होता है. Then there is this error thing. There is a controller over here. Then there is your plant or system. Then there, or this could be like DC motor. Then you have some output, and that output you're sending back to compare with the reference input to generate the error. This is the closed loop system. So this mainly this thing is the feedback कि तुम previous whatever was the output, you are trying to take that into account to find the error and improve the output. So this is closed loop system. Whereas in open loop you do not do anything. See, you just have an input and an output. So you were doing that. So washing machine is an example of such system, open loop system. So the next question is the same. Which of the following is an example of open loop control? What do you think? Which one is an open loop control? Ceiling fan. Okay. So yeah, Ceiling fan is open loop control because in air conditioner you always want to maintain the temperature. This should be the temperature. Servo motor, you have position control. You want to stay at a position कि इतने ही पे जाके रुकना चाहिए. Here it is level control, that water should be up until this level only, not above and not below this level. Whereas in ceiling fan you do not maintain a closed loop control. You try to provide the power and पता चलता है कि हाँ, if I provide, if it drives more, it takes more power, then it is going to move at a higher speed. So that is what you know, and it goes like that. So this is an example of open loop control. Okay. Okay, when the mapping in the feedback path is not equal to 1, it is called as. So here you see, here when I gave feedback, it could have some gain also. Let's say if some k was here, because we can have some gains or we might not have some gain. So if there is no gain, so it is just a line, it is just like a wire. If it is like a wire, just if it is like a wire, it means that the feedback is 1. So when you say the mapping in the feedback path is not equal to 1, it is non-unity feedback. Okay. Okay. In a typical closed loop system layout, the element that takes the controller output and realizes the same to provide it as the system input is called. Means something here, something here that takes the controller output and uses it to provide input to the system. So what could it be out of all the 4 options? Are you aware of them?
Actuator.
Yes, it is actuator. So actuators could be your motors. Actuators could be some pneumatic kind of system that could help in providing you the input. It could be some piezoelectric substance. So these are actuators which would help you to provide an input to the controllers. So you might have seen in the week 1 lecture that there are actuator dynamics that come into play. There are sensor dynamics that might also come into play. So we'll see them later. So dynamics of elements that measures the output of the system and provides feedback. What is this called? Something that measures the output of the systems. Sorry?
Sensor
Sensors
dynamics.
dynamics.
Right, right. Sensor dynamics. So that takes the output from here, then it provides feedback for reference here. So this is sensor, takes the output of a system and provides feedback. Now the next question is the class of linear time varying causal dynamic systems. So this was the thing that was told, that this is the thing we are going to deal with in the complete course. It's typically characterized by
Linear
Linear
ODEs.
differential equation with constant coefficients.
No, ma'am, time varying coefficients.
Yeah, because it is linear time varying system, not linear time invariant system. Time varying is the term used here, so it is going to have time varying coefficients always. So no, what we are going to study would not be this, it would be LTI system basically, linear time invariant, but here for the question it is asked. And it would be linear ODEs because we are definitely going to deal with linear problems in classical control. Then, okay, so having known linear and nonlinear systems for so long, this is this is the equation spring mass damper system. So when you studied, this thing was some constant when you studied the lecture of week 1, whereas in this case this is not a constant and it is something. So what do you think, this function is time variant or time invariant, or it is linear non-linear?
Non-linear, madam.
Yeah, it is non-linear. because you have some xt term with the x dot t term. That's why.
Like, but why can't we call it time varying?
Um, so if you call it time varying, t has to come. So if it were this t into x dot of t plus xt is equal to ft. So what do you understand by time varying and time invariant? I'll tell you. So let's say uh, if it is t, if it is f xt, I'm sorry, just it is xt. Now you have some input. This x is your input, and your output is let's say some this sort of function. Okay, and this happens at t is equal to some t1 seconds. Now when you do this experiment again after 2 3 hours, so I say t1 plus 2 hours, so your input, so this is t1 plus 2 time, your input is this and your output is also this at t1 plus 2, the same output. Okay, then this means that this is time invariant system. टाइम इनवेरिएंट सिस्टम भी मीन्स टाइम बदल दिया, अभी कर रहे हैं एक्सपेरिमेंट 10 घंटे बाद कर रहे हैं, एक्सपेरिमेंट 2 दिन बाद कर रहे हैं, अगर हम सेम इनपुट दे रहे हैं हमें सेम आउटपुट मिल रहा है. Whereas if it is time varying, the result that you'll get now you would not get at some later point of time. So in this case there is no place where t is being explicitly used जिससे टाइम पे फर्क पड़ेगा कि अभी हो रहा है या बाद में हो रहा है. इट इज एक्स टी और एक्स टी इज अ नॉर्मल पार्ट ऑफ द डिफरेंशियल इक्वेशन. इट डज नॉट change according to time. X changes with time, and the factor time does not affect the differential equation. Is that clear?
But like it's the coefficient, right,
X dot
the
t.
of the damping. Like the damping factor here is xt, so the damping factor is changing with time. So the system is changing with time. Like, does it not imply that?
No, it does not imply, because uh, yeah, xt is changing with time, and that is what is making the system non-linear only. That I have two terms in multiplication, but exchanging with time does not make it a linear time variant system, because you do not have a t anywhere that directly impacts the nature of response.
Acha. Oh, okay. So like, if the response is being changed due to change in time, then only we can say it's
Yes,
time varying.
yes. So
Oh,
if
okay.
it was not this way and it was some other way, then that is a problem. You do not get the same output for the same input at some later point of time. That is problematic. And then you
So
have,
like we can say this equation, the system represented by this equation is time invariant, right?
yes.
Okay.
Okay. The complex function, this is singular at what value? So singular at what value means basically that at what value of s you are going to have the response explode to infinity. So it basically means that at what value of s this whole term is going to be 0. So this is like finding the roots. Sorry, someone was saying.
X is equal to minus 1.
Right, s is equal to -1. So this is basically the root of the equation only. That is why. Now yeah, Laplace transform again. So you have the table, and can someone tell me what is the Laplace transform of sine t, sine 2t? Please refer
2 by
to,
s square plus 4, madam.
correct. So it is always like, agar Laplace transform of sine omega t you have to find out, then it is omega upon s square plus omega square. So this is the Laplace transform of sine 2t. Okay, you can see the table, and these are essential transforms. You should uh, you can practice their derivation, but each time you won't be able to derive and use them. So you should have some of these in mind कि sin 2t का क्या होता है, cos 2t का क्या होता है, integration पे क्या होता है, differentiation पे क्या होता है, then what happens if t is multiplied. So there are some very basic things only that are in the table, and try to memorize them. It would be of much help to you. Now see, so in Laplace of sine 2t is this. Now what we want is Laplace of sine e to power minus t sine 2t. Abhi, when this term is multiplied, can you check the table and tell me what are the changes that have to be made in this thing?
S replaced by s plus 1, madam.
Right. So it would be 2 upon s plus 1 का square plus 4. So whenever, so it is a general rule, and I am telling you, there is a sine function जिसका Laplace तुमने याद कर लिया. Now you know what is the Laplace transform for this. Now what you do is you multiply it by a term, and where would that multiplication be affecting you? Here in s wala term. Omega term is going to stay the same, whereas in s wala term you are going to have s minus minus 1, क्योंकि here it is e power minus t, so minus 1, s minus minus 1 का square. So that is why these things come, and here it would be s square plus 2s plus 5. So this is your answer. So please learn the Laplace table. It would be of much help to you, much help. Okay, so yeah, this is a question which I want you to solve. So I hope it is visible properly. Yeah, so it is an LTI system. Now why this is LTI system? You see there is no t appearing, इसलिए it is time invariant. There is no complex function that would make it non-linear, so it is linear time variant system. Throughout the course we will be dealing with linear time invariant systems only. When you'll have some other courses of control systems, advanced control system or so, then you'll have other things coming up, but for this course it is going to be LTI system. Now take the initial conditions to be 0, and let a unit step input be provided to the system. So what is going to happen? So I'll start somewhere and I'll tell you, and then you're supposed to do. So it is y double dot t plus, I want all of you to solve in your notebooks also, 3yt minus 4yt. You have all sort of all such questions in assignment, and you should be aware of this. Now y double dot t is here. Can someone tell what is the Laplace transform for this? You have the table as well, you can refer from there.
S square y by s minus s y 0 minus differentiation y dash
Right,
0.
y dash 0. So what would happen is, okay, I'll write the full thing. Then 3, it would be ys, and it would be y0, right? Then it would be 4ys, और ut को लिख दिया us. Now what you see is initial conditions to be 0. So this is 0, this is 0, this is 0. So what you get is s square ys plus 3ys minus 4ys is equal
3s into ys, madam.
uh,
Yes, sir,
okay,
you
okay,
didn't
okay,
write
okay, I
in
missed
yf.
s here. Okay, okay, thank you. So this is the term. Now ys upon us, it would be 1 upon s square plus 3s minus 4. So basically I'm talking about transfer function since that time. The relation, so here what you find is yt is the output, ut is the input. At this point of time, ys upon us is equal to this thing. You have found something that provides you a relation between input and output of the system. You say ys is equal to something times input. So you have found really the transfer function of a system. What is the system in between when given an input us, what is the output it is going to give. So basically you know what kind of system it is going to be. So this is a transfer function. Another thing in transfer function is when all the initial conditions are zero, then only it is called a transfer function. If all the initial conditions are not zero, you'll get a forced response and a free response. So all of these will be covered, but this is a transfer function and you can know because initial conditions are zero and you have an relation between input and output. Now what I want is, okay, so the value of the output as time tends to infinity is, so I want you to solve this part of the equation basically. So 1 upon s square plus 3s minus 4, it can be written as 1 upon s plus 4 s minus 1. Yeah, it can be written in this way. Now if you have this thing 1 upon s plus 4 into s minus 1, how can you write it as a upon s plus 4 and b upon s minus 1? Please find the value of a and b.
A is equal to minus 1 by 5, madam.
Okay,
B is equal to 1 by 5.
just one thing I have missed here. In the question it was given that a unit step is the input to the system. Unit step is the input means this us becomes 1 upon s. Do you understand? So why I'm saying is this is uh, for unit step what happens is this is called the unit step. Before t is equal to 0 it is 0 and after t is equal to 0 it is constant at a value of 1. That is why it is unit step. Okay, at t is equal to 0 this is the function. So when you take the Laplace transform of this unit step using the whole formula that you have 0 to infinity, what you get is 1 upon s. So this 1 upon s had to be used here. So you multiply this by 1 upon s. Okay, so what you have here is यहाँ पे भी एक s आएगा, यहाँ पे भी s आएगा, यहाँ पे भी s आएगा, and there would be another term c upon s. I had missed this s because since this is a unit response, you have to know what is the input to the system to find out what is the output. Now you tell me the coefficients.
A is equal to 1 by 20, madam.
Okay, correct.
B is equal to 1 by 5.
Right,
C is equal to minus 1 by 4.
right. So everyone should get this answer because it is a simple breaking into partial fraction method, and then you get. So what happens is here is that you get ys is equal to a का value 1 by 20 into 1 by s plus 4 plus what is the value of p 1 by 5 into 1 by s minus 1 plus c का value is minus 1 by 4 into 1 by s. Now can everyone tell what would be yt? Inverse Laplace transform. Refer to the table, you will know the answer.
One by 20 e power minus 40, madam.
Yes,
Plus 1 by 5 e power 2t.
e power 2t.
2t, madam. 1t, 1 t, t.
Right. And
Minus 1 by 4.
yes. Does anyone have any confusion in this? Please ask. I hope it is clear to everyone. Please get your basics right. It is very important. Okay. So I assume everyone is okay with this. So there are just 3 more questions that is related to this answer only and nothing more. So you get the time response. Now what you do say is, so the question is the value of the output as time tends to infinity is. So what would happen when time tends to infinity for this whole response?
It becomes unstable, madam.
Yeah, so what would be the value essentially? Infinity? 0? What? So as time tends to infinity, the first term would be 1 by 20 into e power 0, that is 1 by 20 only. The second term creates the problem. It is 1 by 5 into e power infinity, that takes you to infinity at time is equal to infinity. So yt is also explodes to infinity. So the answer here would be this. Okay. Okay. In question number 13, the coefficient of e power t in the output function is, that you guys have already taken out, and it is 1 by 5. Okay, so 0.2 is the answer. The coefficient of e power minus 4t, so you have taken out this also, 1 by 20, which is 0.05. So yeah, 15th question I want you all to answer. It is related to the answer that you've got. If it is bounded, if exponential, or what are the options, please tell me.
Option A, madam.
A.
Option A, the output is bounded, right? Because that is the problem. Output is really not bounded because at t is equal to infinity it explodes. So that is the, I hope you will be able to solve all sort of these questions in your assignment and get the basics strong. So yeah, in the next meeting which we'll have, it will basically be dealing with the transfer functions. There are something called poles and zeros. which are the not both of them, but both of them are the solutions of a equation like quadratic or fourth order or third order, any sort of thing. So you'll be learning that. Another
Madam,
thing is,
madam,
someone is, yeah,
madam, when will be the next meeting, madam?
next Tuesday.
Next Tuesday, madam.
So you have this already updated in your announcement section also for the course.
Where, madam? Announcement sections. Where can we find that, madam?
Okay, okay, I'll tell you. I'll tell you. Just let me complete what I was saying, and then I'll tell you.
Okay, madam.
So, yeah. How many of you are aware with MATLAB?
Yeah, we have raised the hands.
Yeah, yeah. I'll see. Just a second. Okay, okay. So all of you, to what extent do you know MATLAB? Like, you know to do matrix operations, or do you have some sort of knowledge into symbolic toolbox, or you know something from control system as well? So I just wanted to know.
Yeah, mostly operations on matrices and data analysis using MATLAB.
Okay, okay, okay. So I'll show you the screen. Just wait for 1 second. Yeah. So this is MATLAB, and uh, so you can, so we'll be dealing with many MATLAB problems also in future, since we are still going to enter the course. So I think your familiarity will help. So this is the editor where you write the programs. It is a kind of script. This is the command window where you can access the variables. You can just have very simple operations being performed here. So you can use it. Here is the workspace where you get the data for all the variables and so. So it would be good if you start learning MATLAB. You have MATLAB online for students also available in case you do not have on your device locally. So we'll be dealing with all such things also from the next session. And yeah, so I'll stop the recording first.